So hey nerds, this is Suman and in this video we're just doing another calculus problem. So basically we had started from our just identity relationships with some algebraic functions and started the trigonometric function of sine and cosine, how we can manipulate it, and later on we had got with an exponential term, and now we are going to do another trigonometric function which looks very much symmetric, and it would be very much beautiful relationship that if you had applied or if you had known this result. So the today's integral is going to be sine of 2x, and that is with some disrespect to x, that is a sine squared x plus b cosine squared x, right? So this would be our new integral, and it looks non-intuitive to us because how we can going to tackle it. So it is a very much easy process if you substitute this bottom down here. So let's just put this function with some arbitrary function. Let us assume a sine square x plus b cosine square x is some new variable function t. So now what we are going to do, now we have to differentiate and we have to write dx in terms of some new variable. So this term becomes our t, and in terms of dx we have to write in terms of dx we have to write in terms of dt. So now when you're going to differentiate this function, so let us see here. So if you differentiate sine square x, so if you differentiate sine square x over dx, you get d of sine x squared, and that is going to differentiate with d of sine x into d of sine x with some this with respect to x. So this is going to be 2 sine x into cosine of x. So this is going to be 2a sine of x cosine of x, and in terms if you have cos here you will get some negative sign there, right? So I'm just using that, minus 2b sine of x cosine of x, and this is going to be our dx and this is going to be our dt. So if you look here, the term 2 sine a cos b, 2 sine a cos b is common. That means, and if you know the identity, that is sine 2x is nothing but 2 sine x into cosine of x. So this is going to be our a minus of b sine of 2x dx would be our dt. So in terms of our sine 2x dx, we can write sine 2x dx, we can write dt over a minus of with some b. So now our integral looks like this. In terms of this upper variable, we can write dt over a minus of b, right? And in terms of a sine square, we can write this 1 over t. So a minus b is constant, so we can have to pull out from the integral, and this is going to be dt over t. So this would be very much easier because it's just the log of function. So I would be our 1 over a minus b, and in terms of this we can write n and t with some constant c. So the I would be our 1 over a minus of b ln. So the t is just going to be our a. So t is just what? This much of function. A sine squared x plus b cosine squared x plus with some constant c. This would be our final result. So up to there, bye bye. And if you had any problem, send me.